Lesson 10.4, or sorry, Chapter 10.4, Lesson 2. We're just taking a look at the last functional group that we have for organic chemistry this year, and that is the ester linkage that we're going to look at. So, esters are unique little organic molecules, and they're produced in what is called a condensation reaction. Okay, a condensation reaction, so think of H2O in that one, between two things that we have previously learned. On one side of this ester linkage, we are going to have a carboxylic acid, and on the opposite side, we are going to have an alcohol. It takes these two unique reactants to make the ester. Usually it takes a lot of heat and some acid to be able to facilitate this esterification reaction. But what we get when we successfully react the carboxylic acid and the alcohol is an ester, which just has a unique linkage that you'll see, and water as a byproduct. What's really important to pay attention to here is that it is the OH group from your acid that gets lost, and just the hydrogen from your alcohol that gets removed in this condensation or esterification reaction to make the water. That provides a bond on the oxygen of your alcohol and the carbon in your carboxylic acid fragment. And so you can see that you have the remainder of your carboxylic acid now being bonded to the oxygen that you had in your alcohol fragment. Okay, so the unique thing that we see in an ester linkage is two carbon chains linked by a single oxygen. We will also see that carbonyl group left over in the carboxylic acid fragment right next to it. Okay, so again, the complexity in this one makes it easy to identify, but we'll be looking at this one more from esterification reactions, knowing the two reactants, one being an alcohol, the other being a carboxylic acid, and then making the ester and water. This is a lab that we would normally have done. It's really fun because your esters are known for a lot of the scents and smells that we get, be them artificial or naturally occurring. All right, so we normally associate these things with scent and aroma. This is what gives flowers and fruits their unique scents. It's also some of the synthetic ones that we kind of see. So for your blue raspberry Slurpees, they have a unique scent because of the unique ester that we would dope these things with in order to give them that pleasant aroma. Okay, we also see them as fats, your triesters and polyesters, if we're getting into polymers for your synthetic fabrics. All right, so there's a lot of application to the ester class of organic molecules. You can see in the general formula that you do have two carbon chains, so that little apostrophe there is just to show that you have a differing carbon chain on one side versus the other. We can have methyl groups, so sometimes we can just see the H if we just had, let's say, the remainder of our methanoic acid. Okay, we would only have an H attached here, and so sometimes you'll see that general formula. Again, the general formulas aren't all that common. We're into the nomenclature here, so don't worry about that so much, other than being able to recognize the linkage. Okay, next, moving on to naming these things. Much like your carboxylic acid had a two-part name, the alkane remnant and the word acid separated by one space, your esters also have a two-part name. The two parts come from the remnants of your alcohol and your acid. It is important to remember that there's a single space between the two parts of the name. Okay, so when you are entering these into your Chapter 10 quiz, again, pay very particular attention to how you are typing these in. Spelling will count. Appropriate spacing will count when you get to carboxylic acids and your esters. Again, no spaces for branches, no spaces for any of the other hydrocarbons or hydrocarbon derivatives that we have looked at. Again, be really, really careful with that one. So how specifically do we name these esters? Well, the first part of the name is from the remains of the alcohol. So it is your alcohol that you find that gets named first. The suffix of the alcohol gets changed from its original OL to now a YL because it's lost anything that made it an alcohol. Okay? With this, it is a more similar to an alkyl group, so we're going to name it as such. The second part of the name comes from, obviously, your carboxylic acid, the second reactant in esterification. Okay? Our suffix here was originally oic acid or ic acid, and so it's no longer acidic when it loses that OH group, and we'll change the suffix to oate. If your alcohol comes from a benzene ring, remember that it is called a phenyl when we're dealing with those ones. If any branches appear, we will name those accordingly for each relative part of the ester group. So here is a guided example that we can look through. We have your alcohol, we have your acid. We can show these to you guys in any order. I like to try and write these out, or when I'm working through them, always work with the alcohol first because it is named first, and then I will deal with my carboxylic acid and name that part second. Okay, but it doesn't really matter how we draw it, just so long as we know we are supposed to name the alcohol part first and then the carboxylic acid part second. Once they are in the ester, we kind of look at them as fragments because they're no longer alcohol and acid anymore. So you can see here that we have methanol. All right, you have your OH group, and it is the H that is going to be lost from there. For your ethanoic acid, it is the OH group that is going to be lost, and those two make the water that we see as the second product of an esterification reaction. Now you have a bonding site on your remaining carbon here, your terminal carbon in the carboxylic acid fragment, and you have a bonding site on the oxygen. So that's where the linkage is made. Now we have the acid fragment with one carbon in it, so methanol just gets turned to methyl, and then we have a 2-carbon acid fragment. All right, so ethanoic acid now just becomes ethanoate. Again, the space here. So methanol and ethanoic acid in an esterification reaction produce water and make methyl ethanoate. All right, acid fragment name with the new YL suffix, and carboxylic acid, alcohol fragment with the suffix change, and the carboxylic acid fragment with the suffix change. Okay? There we go. In the next video, we'll get through some of the examples with this. We'll practice drawing them out, and we'll practice writing the reactions. Okay, so we'll see you in part 2 shortly.